Ready.
Good evening, everyone. I am Hammad Majeed, and I shall present about the application of auxiliary materials in the field of protective textiles. Before going into detail what are the auxiliary textiles, we should clearly understand what actually happens when a bomb blasts. First of all, the blast wave from the explosion creates very highly compressed air particles that push into that spread into the surrounding environment, and any fragmentation of the bomb or any shrapnel included in the bomb, they are thrown outward at very high speed. The explosion creates fire and heat that may cause secondary explosions and heat. And immediately after the spread of shock wave, the cool air wave from the surrounding that start to target where actual blast happens. You can see that buildings and any other material or any other object which is in the vicinity of the bomb explosion that can be pulled at very high speed. The main hazards of the bomb blast are primary fragments from the bomb that can move at the speed of 68 to 136 miles per hour, and the pressure of the blast wave is very high, and massive pressure can cause building damage, and you can see that only 15 pounds per square inch can rupture eardrums and cause permanent lung damage. In many instances reported in Afghanistan and Iraq war, that the people who have suffered from the bomb explosions in their close vicinities, that they may appear physically unharmed, however their brain had been damaged during the process. Secondary fragments include the shrapnel, rocks, glass, etc., and that may cause the heat and fire created by the explosion may cause secondary explosion. And higher pressure waves can even cause structural collapse. If you look at the anatomy of the blast event, generally it is expressed as trinitro load equivalent, which is used to express the power of the blast, and it is dependent on the type of explosive used, the standoff distance from the building or the target area, and the charge where charge has been put up, and the height of glazing if we have used glazed glasses to protect the indoors from the outside blast. Bomb blasts cause the collateral damage that include loss of life, damages to the property, and the destruction of the businesses. Generally, wherever a blast happens, the blast wave generally spreads throughout the street. It does not go into the atmosphere outside, and the streets act as channels to receive the blast wave, and areas wherever blast wave passes through, the glasses of the windows and the doors in the building may cause secondary damage. There is no such thing that could be used as blast-proof windows or doors. If we target to create or make truly blast-proof doors or the windows, those would be very heavy in weight, and existing building structures may not even withstand the pressure. And in addition, those windows and glasses and doors will not be see-through. University of Exeter has created some materials that could be used as blast mitigation purposes. As you can see in the picture that Professor Can Ivan of the University of Exeter is showing the auxiliary materials. It has been developed by collaboration of the University of Exeter, UK and Organic Technologies, a spin-off company of the University of Exeter, they have licensed its commercial rights to advanced fabric technologies using sector of USA. It has been primarily designed to be fixed over the inside of the windows, which are windows in the building which are potential terrorist targets, such as government offices and high-profile commercial properties. And glass curtains currently used consist of thick net curtain fabric, which are applied in conjunction with anti-shatter film applied over the glass of the window. The new curtain will remove the need of using anti-shatter film by using stronger, more resilient fibers woven into a carefully controlled textile structure. At just 1 to 2 millimeter thick, the new type of curtain will be designed to let in a reasonable amount of natural light, so thereby reducing the need of electricity for lighting purposes inside the building. It has got recognition over the world by winning Global Security Challenge of Peace semifinals in 2007 and 9, and Innovation Prize of Textile 2007, Performance Textile Citation in 2008 for Innovation and Excellence. First, I will tell you what are organic textiles. Organic materials are found in nature, for example, in cat skin and bone from the human skin as well. To understand the concept of the organic textile, consider the length of a bungee cord. If you stretch it out, it gets thinner. And if a piece of twine or some hard material is wrapped around the bungee cord, the cord effectively becomes thicker when the twine is drawn taut. That is the actually idea behind organic. The bundles of organic fiber wrap get thicker when stretched out. Such a fabric could be used in blast-resistant purposes and in many different capacities. Here you can see that Dr. Patrick Cook, managing director of Organic Limited, is showing the basic materials made at the UK. Organic fabric currently marketed by the brand Etc. These are organic materials actually increase in size on stretching, which are very high, dense, absorb and disperse energy from explosions without breaking. High performance materials are combined with cheaper birth components in a 1:100 ratio, and blast resistant properties of high performance materials are maintained. The only material on the market that automatically adjusts its strength and thickness in response to explosive force. It comprises of a series of organic yarns, each yarn wrapped using S or Z twist with a high strength power thread. Organic effect is determined by the precise angle at which the second fiber is bound around the first fiber and by the two fibers' relative thickness and diameter. Yarns are then woven by left insertion across the bar by completely conventional processes. Off the loop, the wax becomes a tensile element in the fabric. When force is applied, the organic yarns deform, opening thousands of small pores in the fabric surface, and you can see the difference in these pictures. The elastomeric core acts as the integral shock absorber. The pores allow high energy blast waves to weld through the material, significantly reducing the load imposed on the fixture. Preliminary data are showing that curtains give a 25% reduction in impulse wave pressure. The spiral windings of high strength fibers catch any ballistic fragment, for example, glass shards, tablets, reducing injuries, and thus potentially saving lives. The fabric returns to its usual state when the stress is dissipated. Basic etc. fabrics have been tested with Honeywell, Spectra, and DSM's Dyneema, wrapped around polyester monofilament and ballistic nylon. Strength of these materials can immediately be increased by probably 80 to 85% by substituting Vectron for ballistic nylon, which is actually nylon thickness. Currently, fibers under investigation are Kevlar, Vectron, Nomex, Hydrals, steel, titanium, and carbon fibers. The important properties of the fibers, which play an important role in the manufacture of these materials are elongation at breaking tenacity, initial modulus, density, LOI, thermostatic melting point, etc. As far as performance testing of the organic materials are concerned, initial tests conducted at UK are confidential and their data is not accessible. Advanced Fabric Technologies is currently working with independent testing labs for performance data. However, they have published that the single layer of extragraph fabric, which stood shrapnel from a rocket propelled grenade detonation from a distance of 1.5 meters, and a single layer of extragraph fabric survived 8 consecutive grenade blasts from a distance of 1 meter. Potential application areas are for use as glass curtains, for shrapnel protection within buildings, and for safety of the explosive ordnance disposal workers. The fabric thickness and strengthens as it is impacted by the glass, shrapnel, and other materials. Other areas include lighter compact vehicle armor that improves the performance of the military personnel. Since it is a lightweight alternative for enhancing vehicle protection when employed in seats, interior lining, and large shield business. Other applications include military tents to protect against bomb, mortar, and grenade attacks during the battlefield, interwall glass sheeting for buildings in the commercial and sensitive areas, anti-fall lining for aircraft, ships, and land vehicles, shielding for mining operations, enhanced bulletproof vests, and body armor. With that, I thank you all for your patience for listening.